Meta's new agent model launches locally with one command. The difficult question begins after it loads. Meta released Muse Glimmer on August 10, 2026. Its pitch is an always-on local agent for tool use, coding, file work, and multimodal reasoning. What shipped is a dense causal transformer, not a mixture of experts model. Meta lists about 29.6 billion total parameters, including a roughly 1.8 billion parameter VTG14 perception encoder. It accepts interleaved text and images and produces text. The context specification is 131,072 tokens or more, and Meta gives it a January 4, 2026 knowledge cutoff. The defining twist is the teacher. Meta distilled Glimmer from Muse Spark, its larger closed model, and explicitly describes Glimmer as generally less capable. Distillation transfers behavior from a teacher into a smaller student. Meta says pre-training use Spark's outputs and log at distillation, followed by agent-heavy mid-training and post-training across reasoning, coding, and agentic domains. That makes Glimmer neither Spark with a download button, nor a miniature copy with identical judgment. It is a student optimized for a narrower deployment target. The release is genuinely permissive where it counts for reuse. Meta publishes the artifacts under Apache 2.0, including full precision weights, 2 quantized variants, the perception encoder, and the DFlash drafter. That still means open weight, not a reproducible open source training project. Meta describes broad data categories, but it does not release the underlying training dataset or a complete recipe for rebuilding Glimmer. Now test the laptop claim. Meta's full precision target is 64 gigabytes of VRAM. Its dynamic quant targets 32 gigabytes with 0.2% average degradation, while the smaller quant targets 24 gigabytes with 1%. Olima's initial package is Muse Glimmer 30B-MLX, a 21 gigabyte Apple Silicon build with text and image input. Olima says support for NVIDIA, AMD, and other platforms follows in the coming days. A model fitting in memory is not the same as every feature fitting comfortably. Context, image perception, the KV cache, and speculative decoding all compete for the remaining headroom. Meta compares Glimmer with Google's Gemma 431B and Alibaba's Qwen 3.627B. These are Meta's self-reported evaluations, not independent league standings, and the pattern matters more than a single winner label. Glimmer's clearest advantage is multi-tool orchestration. On MCP Atlas, Meta reports 75.5 for Glimmer against 62.5 for Qwen. Deep Search QA is 74.6 and Wildclaw Bench is 47.6. That profile fits an agent coordinating calendars, files, search, and structured tools. The strength is not merely answering one difficult prompt. It is keeping several interfaces aligned across a longer task. The same table prevents a sweeping victory claim. Qwen leads Meta's reported OS World score 75.6 to 65.9, Terminal Bench 60.7 to 51.7, and SWE Bench verified 77.2 to 76. Glimmer also reports 94.7 on AIM 2026 and 80 on AALCR, yet its GPQA Diamond result is 83.5, behind both comparison models, while multimodal results mostly sit near parity or behind. Here is the useful reading. Benchmark shape predicts product fit better than benchmark average. Glimmer's peaks cluster around orchestration and long horizon agent work. Its weaker results cluster around direct computer operation and terminal execution. That distinction matters because an agent can choose the right tools while still mishandling the tool's output. Planning quality and action integrity are separate properties, and only the second protects your actual files. One independent launch day test on a 24 gigabyte M4 Pro measured 10.13 tokens per second in direct text generation. Adding a CPU offloaded DFlash drafter reduced that to 6.73, making the tested run 33.5% slower. Meta reports DFlash speedups from 1.5 times to 3.1 times on different hardware and runtimes. The contradiction is practical, not mysterious. Speculative decoding depends on where the drafter runs and whether memory pressure forces compromises. The same independent test hit an out-of-memory failure during sustained work with vision and longer context enabled. A 24 gigabyte machine ran the text agent, but not every advertised component together with comfortable margin. The sharper warning came from file organization. The agent reported success, but 4 copied files each lost a final new line. Only an independent SHA 256 comparison exposed that every copy was 1 byte shorter. The correct local agent pattern therefore includes verification outside the model. Run the task, hash the outputs, compare them, and reject the change when integrity fails. Fluent confirmation is not evidence. Meta says Glimmer is trained for failure recovery. The launch materials describe diagnosing failed tool calls and retrying, but they publish no dedicated failure recovery benchmark that quantifies reliability. The benchmark closest to Meta's personal agent pitch is Gaia 2, where Meta reports 43.3. It is the lowest Glimmer score in Meta's published general agentic table, despite exceeding the 2 comparison models there. Local execution does remove a cloud model provider from the inference path. It does not secure the surrounding agent. Tool permissions, file system scope, network binding, logs, and approval gates remain the real safety boundary. The verdict is specific. Glimmer is a credible downloadable agent model with an unusually permissive license and real orchestration strength. It is not Spark, not uniformly best in its class, and not comfortably all features at once on minimum hardware. Muse Glimmer makes local agents more accessible. Trustworthy local agents still require external checks, narrow permissions, and hardware-specific testing. This is NextToken.